Hey everyone, I'm Tim, and I'm going to be talking about Move 2024. So kind of this is the next evolution of Move. Okay, there we go. So in Move 2024, it's kind of like the next evolution of the Move language with a bunch of new features and a bunch of new things coming in it. And when we kind of set out to develop these features, we kind of set out with 3 goals in mind. The first of these was to make the language a bit more expressive, right? So allowing developers to kind of more elegantly create things in the language, solve problems, those types of things. The second of these was to allow you to write, clearer, more concise code that's, kind of more understandable and just kind of easier to understand in general. And then the third of these was to kind of really create a foundation for the future of the evolution of Move. So kind of laying the groundwork for features to come, not just now, not just this year, but kind of in the years to come. So with that, let's take a quick look at some code written in legacy Move, and then we'll take a look at that same code in Move 2024, and just to give you a bit of a taste of some of the features. So here's some code. It's pretty standard Move code. We use standard vector. We declare a struct. We declare this function split n, which takes a coin, splits it into n different coins, all with an equal value. So we're getting the value in places. We're iterating over some stuff. Kind of pretty standard, normal Move code. And this is that same code in Move 2024. Oh, sorry. Thank you. So the first thing you'll notice is the code's a lot shorter, so that's always a good thing. But there are a number of other smaller things that have changed in this code to get there. So let's take a look at those one by one. So the first thing you're going to notice is kind of what's not there. So in particular, there's no use statements, right, for standard vectors. So in Move 2024, there's default imports for a lot of the standard modules like standard vector, option, Sui object, Sui transaction context, and the like. The second thing you'll notice is that the function calls are different. So whereas before we had something like coin, : value of self, now we replace that with a method call to self.value in those places. And then the third of these you'll notice is this kind of new function call that we have here with a bang, and this is because that's a macro. So this is, in fact, creating a vector of size n-1, and then for each element, it's calling self.split with the amount that we give it. And then the last thing you'll notice is the change in the struct type. So it's not just struct coin, but public struct coin. And this is kind of that nod to the future of kind of setting the groundwork to allow us to have private types or public package types at a later date. So it's not in Move 2024, but kind of laying that groundwork for the future. So we just saw a couple of the features, and there are a ton more coming. So today in Move 2024 beta, these are kind of all of the features that you have available. So method syntax, index syntax, a bunch of other things, and we'll go to those in more depth here in a second. Kind of coming soon, so just around the corner, we're just finishing up macros for Move. Enums along with matching in the source language, and I'll call out clever errors as well, which will allow better error messages, more human readable error messages, so you not just abort with code 0, but something like not found and an actual string that you can read or something like that along with it. And then kind of this year, we're working on improving the IDE, making the LSP better, more resilient parsing, these types of things. And we're also working on an auto formatter for the language. So let's take a look at kind of each of these in a bit more detail. So the first thing is method syntax, which we saw before. So now instead of having to call coin value, I can just call the value method on it. Index syntax, so you can now index vectors the way you always wanted to be able to all along. But you can also do this with other collection types as well, and even collection types that you define, and we'll see how to do that here in the second half very briefly. I'll touch on it. The third of these is positional structs. So you can have structs without named fields, and you can access them via their position, so .0 or .1. Break along with values, so you can iterate to some fixed point and then break out of that loop with a value. Named loops, so you can have inner and outer tags for your loops or other tags, and then break between those loops. So it's kind of making the control flow graph of the program much more kind of transparent, and you can kind of grab it with your hands and make the control flow of your program much more easy to understand. The second to last of these is package visibility. So there's no more friends in Move 2024. In fact, friends are deprecated. And instead, what you can use is public package. So this is saying this function is visible within my package, but not visible outside of that package. So you no longer have to have some lengthy friend declaration and test only friends or anything like that. You can just say public package. And the last of these, as we already saw, is default imports for a lot of the standard modules. So coming soon, just around the corner, we've got macro functions here. So here we have a little macro declaration for map. And we'll get into macros a bit more in the second half of the talk here. We have enums along with matching on these. So if you're familiar with Rust enums, this should feel fairly familiar to you. But you can basically have an enum with various different variants in it that can contain data of different shapes and types and these types of things, but all be treated as the same type. Type holes. So in the source language, if you find a place where you're like, I need to write it down a type here, but I don't care what type it is, you can just do an underscore in the compiler, and that basically tells the compiler, just go and figure it out and fill the type in there for me, please. Then we also have clever errors. Again, as I mentioned, much more human-readable errors in Sui. So instead of aborted with code 0, it will give you, in this case, e not found, and then the string element not found, along with the source line number in the source program where that assertion failed. So if you have the source code available, you can then track that back to the specific line number where that assertion failed. If you don't have the source code, obviously can't do that. And then finally, we have named blocks. Again, kind of exposing the control flow graph of the program and kind of allowing the programmer to get a handle on that a bit better. And this will be especially useful for macros. And then kind of throughout this year, we're going to be working on improving the IDE. So again, better resiliency in parsing, better go to definition, go to references, automatically importing things, these types of things. As well as we are working on an auto formatter, so you can solve the great debates on PRs and the like of like, oh, this line should be, this is too long, this should be broken here, it should be indented like that. So those things will be coming this year as well. Okay, so ton of new features, ton of new things. And then you're probably saying, well, I have an existing Move package, and I haven't been able to use these existing features. Like, how can I use this all? So let's go into that. So here, if you can see it, yes. We have a very simple, existing move.toml for a Move package. We have a name, a version, and nothing else. And this will use legacy Move, and we'll always continue to use legacy Move. So if you then want to use the Move 2024 features, you then need to add this addition field. So in this case, I'm setting the addition to 2024.beta, but eventually it will just be simply 2024. Once all the features are there, everything is kind of frozen. And the reason why it's an addition is because additions allow us to introduce kind of breaking syntax in the language without breaking existing packages, right? So we don't want to like roll out changes to the language, have you using it, and then suddenly, you download a new version of the CLI, and then all of your packages start blowing up, and you have to spend the next week or two refactoring things. So additions allow you to kind of opt in when you're ready to and do that migration when you have time and are able to. But we have also worked hard to make that as easy as possible, as we'll see here in a moment. So I just said kind of a magic word of breaking changes. So you're all probably now wondering, like, what are those changes? And how painful are they going to be? So one, they're not going to be too painful, trust me. But let's go through them here in a moment. So the first thing, and this one's a pretty simple one, is simply there are no just struct declarations. All struct declarations have to be public struct, again, with this eye towards private types and public package types. The second of these, which is a bit harder, is mute is now required on modified locals. So before I could write, let x equals 10 and then set is x equal to x plus 1. Whereas now I need to say let mute x equals 10, and then I can mutate it. So it's making kind of the mutation or what variables can be mutated in the program kind of much more transparent in the source language. The third of these, which is a bit of a breaking change, it's not too onerous, but nevertheless is breaking, is there are new keywords. So if you had a function named type or a variable named mute, those are now keywords, and the compiler will complain at you unless you kind of escape them. So it's not hard to escape, but nevertheless, you now need to escape them if you're still using them. And then the last of these things is namespaces are combined to allow for enums. So what this means is if I had a module named A and a function named A, and I was importing them both simultaneously into my module, before it'd be fine. Whereas like now, the compiler will yell at you, and you need to rename one of them to some function of A or something like that. So again, not too bad of a change, but nevertheless, a breaking change. So you're probably, I keep talking about breaking changes, and you're probably feeling a bit like this, but fear not, because there is a new command in town, and it's called Sui move migrate. So if you have an existing move package out there, and you feel free to break out your laptops during the talk, I would encourage you even, go to your favorite package, run this command, and it will do all of the breaking changes for you. It will do that migration. It will say, like, do you want to migrate to Move 2024? If you say yes, it will generate a diff. And then you can either choose to apply that right then and there, or just save it. You can audit that diff and then apply it at a later date if you want. But this takes care of like all those changes, public, struct, let mutes, like all these types of things. All the things where you're like, I don't want to sit down for a week and handle this all myself, right? It just does it one and done. Then you can do the fun stuff of like method syntax, cool index syntax, all these types of things yourself, right? So definitely check out that command. Okay, so the second half of this talk, we are going to give you a very brief taste of Move 2024, some of the bigger features, and it's going to be a whirlwind tour. And in fact, it's going to be way too much for one presentation. I'm going to be going really quick. So definitely check out the movebook.com or the movebook reference. Here, we'll get out of the way. And this will have a migration guide, as well as go into detail for all of the different new features in Move 2024. So this goes in a lot of depth for everything I'm going to cover in this talk, and a lot more in depth. So with that out of the way, we're going to take a look at three things: method syntax, macros, and enums. And method syntax is in 2024.beta. So let's start out with that. So here I got a little function on the right, and it's purchase, and I give it an ID of an NFT I want to purchase, and a coin for payment. And as you'd expect, kind of in this function, there's this assertion to say, make sure that the price that I want for this NFT is equal to the payment's value. So that payment.value is a method call. And method calls are resolved actually underneath everything when it gets all compiled down to functions, to normal function calls that you see today in Move 2024. But how that is done is actually a really interesting process. So let's take a look at that. So what's going to happen here in particular is the compiler is going to see, I have a value called payment, and its type is coin, and I'm calling the method value on it. So how do I figure out what function value should resolve to? What it's going to do in this case, it's going to go to the module that defined coin in this case, the Sui coin module. It's going to look for the function called value, and then it's going to kind of compile that into that function call. So into this Sui coin value function call. But there's an additional character there. There's that reference. In particular, the compiler is smart enough to say, you're calling the value function in the Sui coin module, but that takes a immutable reference to the coin, but you're giving me a coin by value, so I will automatically insert a borrow for you, right? So it's being kind of smart behind the scenes for you in figuring that out. And this kind of works for all of the different things, right? So like if I have a function foo that takes the object by value, I call it as o.foo. If I take it by immutable reference, same thing, o.foo. And if I take it by immutable reference, again, the same thing, o.foo. The compiler is figuring that all out for you, hold on, behind the scenes, based upon the type that you are calling it on, and then based upon the type of that first argument, right? It's doing type-based resolution. And this type-based resolution is actually really powerful. and you can do a lot of fun stuff with it. So just as a brief example of that, here I have the Sui object module, right? And inside this module, there's these two functions, UID to address and ID to address, which kind of do what you would expect. You know, you give it a UID, it gives you the underlying address. I give it the ID, it gives me the underlying address. So kind of exactly what we have already. But they can't be named the same thing because they're functions. And you can't have functions with the same name in the same module. But because methods are type-based in their resolution, you can have two methods with the same name that resolve to the same two different functions. So this is where these method aliases, or this use fun that you see here on the left, comes into play. So what this is saying is this use fun UID to address as UID.toAddress is saying if I see a value of type UID, ref UID, or mute ref UID, and I call the method toAddress on it, that's going to resolve to the function call UID to address. That public in front of it in this case is saying, since I'm in the module that defines UID, I can export this method alias from my module so that other modules that use me can use that method alias as well. So this is kind of exporting it out into the public namespace so that other people can use the same method alias. Similarly, for IDs, I can say if I see an ID value and I call the method toAddress on it, that should resolve to the function ID to address, and I'm going to publicly export it. And in particular, these are the same name, but they resolve to different functions based upon the type that I'm calling them on. Right? So this allows kind of cleaner APIs, right? I can just say there's a toAddress method, and then I can have that resolve to different functions based upon the type that it's being called on. So this is great. You can publicly export these method aliases. Awesome. But what if a module doesn't define a method alias that I want, or I want to change the meaning of that method alias locally within my module? Well, this is where method aliases, local method aliases really kind of come into play. So here on the left here, I have the empty byte vector, and I'm calling the length method on it. This is just a simple vector length. It'll give me 0. Same with if I get the length of the byte vector containing hello, gives me 5, just as I expect. But I now want to change my module, and I want length here to call this function here on the right, this non-empty len, which will abort if the length is 0, and otherwise just give me back the length. So I can do this with a local method alias. So the same thing as before, just no public in front of it, but this is saying locally within my module, if I see a value of type vector, or ref vector, or mute ref vector, and I call the length method on it, that should resolve to the non-empty len function. So now, when I call length in my module on the empty byte vector, it's going to give me an error, because it's going to say, what's the non-empty len of empty? Well, that's an abort. And then for hello, it'll say, what's the non-empty len of hello? And it gives me back the same answer. Right? So this kind of allows you to kind of customize your local method aliases to kind of fit your needs. Right? Like, oh, I want to override the meaning of this method locally, or I want to introduce this method just within my module, but I don't own the type, and these types of things. So there's a lot of power that you can have here. But there's more. Type-based resolution can go a bit further. So, and in particular with index syntax. So there's rules around the signatures of these types, or of these functions, which is gone into in the move book. But basically here I have two functions, borrow and borrow mute. The names don't really matter, but basically, I have some container or some collection, I take a key, and it gives me back, the immutable reference or the mutable reference to them. And I have some function calls down here at the bottom. But what I can now do is I can add these new annotations, syntax index on these functions. And now I can index that container using index, right? I can just say container indexed by key, or container mutably indexed by O key in this case, and that will resolve to those function calls of container.borrow or container.borrowMute. So this has a lot of power in terms of you can start defining your own collections, these types of things, but exposing a kind of native feeling interface to those collections, right? Okay, so that's a very brief tour of method syntax and index syntax. Now we're going to kick things up a notch and go even a bit faster maybe, and take a look at macros here. Brief whirlwind tour. So here we have a macro. Don't try to parse everything in it. We'll get to kind of the special parts here in a little bit. But basically, all this does is it says, for each vector, I'm going to take a vector, and then for each element in that vector, I am going to call this function body on it. So let's kind of step through each of the kind of constituent parts of this macro. OK, so the first thing you're going to notice is there's a new declaration form in town. So there's now a public macro fun instead of a public fun. And this is a very important distinction because importantly, macros do not exist in the compiled output. Right? So you can't call each from a PTB. You cannot call any macro function from a PTB or anything like that. They are completely compiled away. So what you should really think of these as is kind of very basically as like rewrite rules or kind of, I don't want to say very, very fancy static inline, but it's kind of like that. But these are largely you specifying rewrite rules to the compiler of this is how you should rewrite the program with this. And to reinforce that in some sense, right, macro parameters take this weird $ in front of them. And this is really to kind of reinforce the fact that you are not passing values here as you do with functions or these types of things. You're really passing bits and pieces of the program's AST and actually expressions that are kind of being stitched and kind of like shoved in different places by the compiler during compilation, right? So all of this is getting compiled away, right? It may look like a function, it may look like a function call, but really these are pieces of syntax that are getting kind of stitched together and rewritten by the compiler based upon these rules. Then here we have this loop body that we apply. And again, this is where it looks like function application, but it isn't actually function application. It is substitution in the compiler. So basically, that function body that we supplied will be completely inlined in this location, and you will actually not see any function call here in the compiled output. So we can take a look at how we can use this here in another little example called collect_odd, which takes a vector of U64s and a function for each to be called on each odd number in that vector of U64. And here I say for each x in x's, right? And I say if x is even, return. So that's going to basically skip to the end of the lambda body there. Otherwise, call that function, right? So now, if I call collect_odd and I give it the vector from 1 to 10, and I just say if it's odd, just push it into the vector, it kind of gives me exactly what I'd expect back, the odd numbers from 1 to 10, right? But you can do this with kind of like, you can define these macros. The world is your oyster to do with as you want with this, right? Like, you can do a lot. These are very powerful things. So it really allows you to kind of customize the experience locally for what you want in the language. OK, so that was a very brief tour of macros. We'll now take a very, very quick look at enums. So they're coming. The first thing that you're going to notice is the declaration form is slightly different, right? It's now public enum instead of public struct. And then they can have abilities just as with structs. They can't have the key ability because it can't have an ID field. But within each enum, there's a number of variants that you can define, right? And so in this case, there's 3 variants that it defines. And these variants can have different types inside of them. They can have a different number of parameters or values that each one contains. They can be positional. They can be named. They can have no parameters. All these types of things, right? So kind of the structure of each of these is independent of the other, but they are all part of the larger type of coupon. And then you would construct them kind of just in the same way you might structs, right? So, but instead of referencing the struct directly, you need to construct each variant within that coupon. So I can construct a coupon value variant, or a coupon % variant, or a coupon free. The last thing with enums is the destructuring. And this is probably the biggest difference between enums and structs, in particular because enums can have multiple variants. So I can't just like unpack it and I'm done. I need to case on each variant and make sure I handle each one. And that's where match happens. So it matches from top down and kind of matches the first variant that matches. So here I have a match arm, and I'm saying if the Coupon is a value variant. Get me the discount field. And then on the right-hand side of this arrow, do write some code to handle that. We also have OR patterns in match, so you can match on multiple variants at once. So in this case, I'm saying if it's a value variant or it's a % variant, I can bind across that OR pattern too. So I can do kind of simultaneous binding. So I can say if it's a value variant or a % variant, get me the expiration from it. Run this little expression, see if it's expired. If it has, go do something. Otherwise, keep on looking for another match. Additionally, here I forgot, a variant, the coupon-free variant. The compiler will complain at you and give you an error if you forget a variant in your matches, right? So it's going to say you're missing a variant here. You're missing this variant in particular. So I can add that in, and now the compiler is happy, right? So there's exhaustiveness in these matches, right? So you can't accidentally forget to cover one of these variants. The compiler won't let you. So there's a lot of other things coming with enums. We kind of just skipped the surface for all of these things. There's a ton more other things that I haven't covered at all. But you can get started today by calling Sui move migrate. And what are you waiting for? Do it now. Do it before you leave this room, right? But we have spent a lot of time to make it as simple and easy and kind of like it should just you run this command and it just works. So it should take all of 10 seconds, maybe 20 seconds. So with that, thank you. And also don't forget to check out the Move book. The migration guide has all of the steps in it, tons of information and everything like that. Thank you.